Hi, my name is Gustavo, and this is my first tutorial on Ableton Live. Today I'm going to talk about motion tracking, how to use an object in front of your webcam to control anything inside Live, from pitch, velocity, or any parameter inside, any effect inside Live. So you can do something like this. Just a second. So, as you can see, this is a patch that I created in Max for Live. So you need Max for Live 6 to do that. Max for Live 6 in Ableton Live 9 because it has jitter. As far as I remember, Live 8 doesn't have jitter in Max for Live. So I'll turn this off and start everything from scratch. So you come here in Max for Live, go to Max Midi Effect and click on Max Midi Effect. Click here to open. I hope you understand a little bit about Max so you don't get too lost, but I'll try to explain the things. So the first thing that we need is the monitor, so we can see what the camera is seeing. So we need this jit.qt.grab, and a jit view window. For this we need a metro for this to work, because it sends bangs like in every frame. So we need to bang frames. In this case, every 50 milliseconds it will bang a frame of the webcam, like pictures. And we need a message to open. And here we have the monitor. I'll do a load bang. It will load a bang to this toggle and to this open. So it starts the monitor every time we start the patch. And another thing, here I'm going to put the size of my window, 220 per 240. It's kind of standard. Okay, so now you see me. Another thing that we can do to optimize our motion tracking is controlling the values for brightness, contrast, and saturation. So we do that with this object. And we need message to control that. Brightness $1, that's a variable, and a number to control it. Sorry, not an integer. You press F for a floating number because it works from 0 to 1. Contrast. Sorry. And saturation. Okay. We plug that on the BR COSA. I don't know why this had this name. Okay, this goes here. and this goes here. Command E, so you can change the values. Okay, here we change our brightness, here the contrast, and here the saturation. Nice, huh? But let's just work with one. Let's going to change it if we need. So here's the ball, glowing ball. So why a glowing ball and why I'm in the dark? Because while doing the motion tracking is done by tracking a color, and this tracking is, and when you're tracking a color, it's much better if you are in the dark with any other colors in the background. So that's how I did my juggling routine, where I created a system to transform juggling in music that you can check it out here in the description. So this is the basics for this system. So how do we track the color? With a jitter object that's called jitter.findBounds. Let's open the help file so you can do what it does. So it scans the values, the bounds. So it's tracking the ball here. So it tracks. So here it will track the bound, the left bound, the right bound, the top bound, and the bottom bound, and will give me the number, the position in pixels that where it is. So we are going to use those values later on to control anything in live. So here the minimum bounds, the left and bottom minimum, and the max bounds, the top and right. So we need to unpack because it has two values. And let's see which numbers it outputs. Our input goes here. You see that it changes for -1. It's kind of bug. We want to see our what is being tracked. So we need another monitor. So another JIT-P window. But this time it's not, the input's not from the webcam. It's from it's created by a JIT.matrix. And there are some things that I don't know how to explain. I just discovered how to do it and copy it. So like this needed prepend, like a message before, with this argument srcdim start, and another one with srcdims m end. Okay, both goes here, and we need another thing, a message that is uses rcdim, and we need a toggle here, and so let's put it load bang. And this goes here, this goes here, and this goes here. No, sorry. This goes here. This goes here. Okay, but before we need, how do we tell git-find-bounds to find the color that we want? So we need to inspect the attributes of this object with this attree. So we plug it here. And you can see that we can control maximum, minimum, adapt, and output mode. We're just going to use these two. Max. Press command to... Oh, you need to put here before. Press command to use this thing in the edit mode. Max and minimum. Okay, so we need to put blue here. This works like that: alpha, red, green, and blue. Each color has a value of alpha, red, green, and blue. You have to figure out what is the value for your color. And I'm not going to focus on that, but I know what is the value for this color. You probably are going to use 1 for alpha always. So now you should see something here. Oh, we need to plug this in the JIT matrix. Oh yeah. Now we have another monitor. So now I want the blue. So red, green, and blue. So max, it's max for the, and it's from 0 to 1. So here it's 1. And I know already the values. Okay, I got a little bit lost, but it's covered. What was the problem? You need to put this uses rcdim $1. So do that, route all the cables, all the cords like that, and put the values for the blue that I discovered that are those ones, and voila, you have the ball tracked. And here, when it's in my right, I have the minimum. Here the left bound, the right bound, and here the bottom bound and the top bound. And you see that's all inverted. I don't know exactly why, but we are going to change that. So we need to transform this in MIDI values for this tutorial. But before, we need to transform those values in MIDI information. But they are from 0 to 320 and 240. So we need to scale them to MIDI values that are from 0 to 127. So, but before that, sorry, we need to find, we don't want 4 values. We just want 1 for the X and 1 for the Y. So we don't want the borders. We want the center for the X and the center for the Y. So we need to do a mathematical expression. So expression here So the first one, $sign integer, because we are working with integer, so I, $sign I, 1, plus the second, that will be $sign I 2, first output plus second output, inside parentheses, divided per 2. I'll put the name of everything left, bottom, right, and top. Left, bottom, right, and top. So left and right here. And we have the center. But I want my left to be the minimum and my right to be the maximum. So we put another thing in the expression. 320 minus this. Oops, wrong places. Okay. So now I have the minimum here with the maximum here. So we do the same thing. With bottom and top. They are inverted too. So we put the maximum value here. That's 240. Yeah, it's working fine. But you see that when we don't have the tracking object, it gives us the maximum. And I don't want that. I want this to be to output 0 when it's not working. So we create an if statement. If the first value $sign I integer 1 is greater than 319, then output 0. Else output the input. Yep, it's working. We do the same thing here, but with one number less than the maximum, so 239. Okay, now we scale this to MIDI. Scale from 0 to 320 to 0 to 127. Those are the range of the MIDI protocol. And we do the same thing. So this is the X, this is X axis, and this is the Y axis, okay? $240. Yeah, it's working. Now we need to transform those numbers, they're just numbers now, in MIDI information. So I will use make note to create the notes, and note out to output the notes. As you can see, this is the pitch output, and this is the pitch input, and this is the velocity output, and the velocity input. This last one is the MIDI channel. We are not going to change it. So here is the number for the pitch, the number for the velocity, and the number for the duration. So we are not going to control the duration with the ball, at least in this tutorial. You can change that. So I will control it with the number. So I to load message to the standard to be 1000 milliseconds, 1 second, to be the duration of the note. Okay, so this is the pitch, so the Y comes in the pitch, and the X comes in the velocity. Oh, before something, the next, let's put a load message here, so because if we close that, when we come back, this will be resetted. So let's choose these numbers to start the program. So 1, 0, 0, 0.55, 59. And here 1, 53, 2. And 1. Okay, so when we close the program, it will and open again, it will open just like we left. Okay, let's see if here we are ready to go. Let's save it. Motion, oh, mode tutorial, don't know why. Close it. Let's open a VST, anything that you want. I'll open a piano. So it's working, but you can notice that if I don't move, it still sends bangs all the time. So how do we solve that? We need to tell the program that if it is the same note, the same number, don't send anything. But if it's different, send the number. So the way I figure out to do that is if the input is different, then output the input. Sorry. So we need to know the number now and the number before and see if they are different. So how do I do that? I create another object that's called pipe, that it delays the signal in milliseconds. So it will delay the signal in 10 milliseconds. So if they are different, it will output. We create that for both. Luckily, we are ready to go. Oh yeah. You can open any VST that you want. And this was a tutorial. I hope you liked it. You like it. And please click like if you liked. Please subscribe. Watch my juggling video. And I'll do a next tutorial to how to control another kind of parameter inside Max, like filters, delay, reverb, with the motion tracking, controlling the API of Live. So thank you.